Sure. So, first of all, hello. I'm Brannan. I'm super happy that y'all are here to listen to me ramble about algorithms for a little while. so, what I would like to do is uh, just talk about the longest common substring problem and the dynamic programming solution to it, or the approach to it. Um, and I'm not going to spend too much time talking about what dynamic programming is. I don't find that useful. I think it's a lot like arguing about the definition of a hammer, right? Um, you kind of know how a hammer works, and as you go through a lot of algorithms, a lot of coding problems, you'll start to notice what you can use these like dynamic programming approaches to. Um, so dynamic one of the parts of dynamic programming, one of the like categories of problems, is kind of like using grids in maybe not an intuitive way, um and particularly with strings and pattern matching. I know for myself, before I like read about dynamic programming, and like watched YouTube videos and stuff, I never would have thought to like construct a grid, or like a matrix to solve these problems. Um, so I think what I'll do here is just share my screen and start rambling at you. I would like to explain this approach, and then we'll maybe pseudocode it out and talk about the subtleties with Python specifically. And then I'd love it if you all tried to program it on your own. You know, come up with a solution. I think for us as Py-Lambdas, we'll get a coding challenge up on the repo eventually here, and I'd like to see everyone's solution. Maybe we can like post them in the code challenge channel and talk about them. And also, if maybe after this you're thinking, I would love to work on these algorithm problems like this, but Brandon rambling at me for 20 minutes didn't really help. I would encourage you to go and look on YouTube. There's plenty of other people that are describing this problem in dynamic programming solutions in different ways. And also, I would just recommend grokking algorithms in general. Um, that definitely helped me a lot. So anyways, go ahead and share my screen here. Boo -boo. I'm just going to start annotating. Okay, so when I say using grids in maybe not intuitive ways, right? What we're going to do is we're going to make a grid where all of the rows are going to represent the characters in our first string. Oh, first, I suppose I should talk about what the longest common substring problem is. We're going to write a function that takes in two strings and finds the longest common substring between them. So the longest list of characters in both of the strings that are in both strings. Right. So if we have so let's say string 1 is ABBA. String 2 is like ABCD, right? What would be the longest common substring between them? And I think we have. Just go ahead and unmute yourself and talk to me. I want this to be more of a conversation than me just rambling at you.
AB.
Right. Yeah. Yeah. Exactly. So that's the AB, right? That's the longest common sequence of characters, or like string of characters. They have to be adjacent. We couldn't have, if we had like ADBA, right? Now the longest substring that's common in both of these strings is one character. Cool. Let me go back to annotating here. Okay. So let's go back to if we have ABBA and ABCD, right? We're going to construct our grid. I could probably do this in a more efficient way, but I'm going to draw like a degenerate like this. All right, so we're building our grid. Like I said before, we have rows that represent a character in our first string, and columns that represent every character in our second string. And what we're going to do is we're going to break this down into, we're going to go square by square here. And we're going to, what we're doing is in this first row, we're going to ask the question, if our string was just an A and just an A, what's our longest substring that they share in common here?
A.
Yeah, right, A, yes. We have A matches A, so we can throw a 1 in here. So we're going to iterate up into our next square. We go, what is the longest common substring if our first string is A, our second string is AB.
Still A.
Still A, right.
So real quick, Brannan, it's not a constraint of this problem that the strings have to be the same length, right? Like, can those strings have been different lengths? Okay.
Yes, exactly. Yeah, they could be totally different lengths. Okay, we're going to keep it iterating up here, right? So our third square here, we're going to say if our first string is just an A, and our second string is ABB, what's the longest common substring there? Well, we still have just an A, right? And then moving up to our last square here, we've got first string is just an A, second string is ABBA. What's the longest common substring there?
I got this one. It's A. It's 1. I got it wrong. I said A. 1.
That was funny.
Right. All right. So moving up through our grid, we can move to our next character in string 1 now, right? So now here we're going, if our first string is AB, and our second string is just A, what's the longest common substring here? I think at this point, yeah, we've got it. It's just 1. Now I want to point out here that there's some things that we would need to check here, right? Okay, so moving up to the next character here. So now we're saying we have AB in our first string and AB in our second string. What is the longest common substring here?
AB.
AB, right? So now how are we using our grid to tell us what the longest common substring is, or what the length of it is?
Oh, that would be a 1. Well, oh, for the length?
Yeah.
Crickets.
So here, what we're doing is we're saying this B matches with this B. So we can add one on to whatever is in this square. Now I want you to think about how this is working. Right? Because we know this B lines up with this B. And when we check the square that is in the like -1 position, we know that that is the character that is one before it in both strings. So string 1, we're going 1 back. We're saying whatever the longest substring is for the characters before in both strings, we can add 1 to that because these characters match. Does that make sense? Is that intuitive? Am I are we all tracking here?
Yeah, it totally makes sense, Brannan.
Yeah.
Cool. All right, so moving on. Our next square here, B matches B, right? Oh shoot! You know what? I screwed up. Ha! We need to put zeros here for all these. A doesn't match B, right? Let's go back in time a little bit.
Oh, so it's not like a cumulative thing.
Yeah.
Oh, that just
Okay.
cleared up a lot. Thank you.
Okay.
That's good. That's good because now it makes sense.
Yeah, I'm really sorry about that.
I'm not gonna lie, I was just pretending like I was getting it when you just. Yeah, that makes a lot more sense now.
Oh man.
So yeah, you're not considering the whole string up to that point then, like the ABBA at the second B. It's just looking at that particular, those two characters by themselves then. Is that right? Like A versus B instead of,
Thank you for doing that, by the
Right.
way. Yeah. So, yeah, we're saying those we're saying A and B don't match there, so it can't possibly be. Hey, what? Get out of here. Like that can't possibly be a matching substring, right? If those characters don't match. I can't believe oh man, I can't believe I screwed it up right off the bat. All right. So we're moving on. B and B do match here, right?
Are
Would it be
we?
a 3?
I'm sorry.
I'm sorry,
Are
go
we
ahead.
looking at the AB string and comparing it then to the ABB?
Yeah.
Or
Yeah.
Yeah.
So
Okay.
we're here.
Okay.
All right. And so we're asking the question, if string 1 is AB and string 2 is ABB, what's our longest common substring here? And so B and B match. So we're going to look to this square. We're going to add 1 to whatever that is. And so here we're going to put a 1. And then we move up. So B compared to A, that doesn't match. We can put a 0 there, as we all know now. And now we continue iterating up. So we're in the third row. Our first string is ABC. Our first letter is A. C doesn't match with A. We can put a 0 there. Moving up. And I'm going to start drawing these out really quick, as long as no one's super confused on what we're doing here.
No, go ahead.
All right, so C and B, right, doesn't match. C and B doesn't match. C and A doesn't match. And D doesn't match any of these in the first string either, right? So what's our longest common substring here? Well, we already said this in the beginning, right? It's AB and AB. And we know that because this is the largest value in our entire grid.
I have a question.
Sure.
Are we looking for the number 2 or are we looking for A and B? What is the answer that this function is to return?
Yeah, so that's a good question. And this totally depends on what we define as the requirements for our challenge. I've definitely run into them on sites where it's just return the length. But if it was return the actual substring, what would we need to do? What could we do in our function to return it?
I guess it depends what substring we need to return.
Well, in this case, we need to return AB, right?
But it can be different.
It could be, sure.
I mean, it can be 3 substrings that have 2 length 2. So we need to return the first one or the last one or the one in the middle?
Yeah, let's. I think we can define that ourselves, right? Let's return the first one.
Okay.
Yeah. How would we do that though? How do we even return this? What would we need to do in our function? We would need to like keep track of what the maximum is, right? So what would we need to keep track of to return the actual substring?
Well, we would have to set a maximum length, variable, right? And then I'm trying to process this.
I guess we can use just the index.
Yeah, definitely.
Yeah.
Right. We could keep the index. So we could just keep a store variable like our maximum length, right? Up until this point, it would be 1. And then when we hit here, it's larger than our current maximum. We'd hit 2. But we could also keep track of our index. And when we get here, we just keep track of the index in one of our strings, right? So in string 1, that's index 1. And we know our substring length is 2. So at the end, we could just slice that part of the string out. Maybe that's also me just rambling at you, but we'll get into the pseudocode here and talk about how we can actually do that. Okay, do you all want to go through another example, or can we start talking about how we're going to do this in Python?
I'm ready to move on.
Cool.
Yeah.
And if that's not intuitive yet, how this grid works, I would suggest like just writing out an example of your own on pen and paper and go through it.
Yeah, the other part that gets confusing is like when do you aggregate the top string versus looking at them cell by cell, right? So you've got a grid, and you're actually when you compare A and A, then you have a result. When you compare A to, so you're going across the top cells, comparing individual characters with each other. And then when you get to the second level, you start to compare.
I think I get what you're saying. We'll only ever be comparing one character to one other character. And that way, can I?
I don't understand the question. What is the question?
Let me just draw this out again real quick. And boop.
I think it would help, Brennan, if you used a different one. We've seen this one, so can you use a different example?
Well, I just wanted to point out that the way this works is each of these diagonal lines is like a run of characters in both strings. So that's why when we get here, we're only comparing B to B, but we're adding whatever was before it. We're adding 1 to it, right? So like this line here is the entire string for both of them, right? This represents A compared to A, B compared to B, C compared to B, and D compared to A.
Oh, okay. So that's kind of a special characteristic of this grid. It's not like a normal grid. You would not do that.
Sure. I mean, like, so this style of like this approach to solving like pattern matching problems, it can be applied to like a lot of different challenges. But yeah, I think it's not intuitive to like think of grids like this,
No.
right? Like you don't look at a grid and think like that represents a character or a string, like
No.
yeah. But that is like this diagonal here, right? Then this square specifically represents B compared to A, C compared to B, and D compared to B.
Yeah, I follow that now. So
Cool.
does this work if um, these two strings get really large?
Yes. Yes, it does. If it gets too large, we're going to start running into memory problems.
Well, yeah.
Yeah. And I would like to point out that this is not the optimal solution to this problem. And if you found this useful in the future, let's talk about those more optimal solutions.
Are you talking about like a sliding window?
So there's another solution that is kind of like a sliding window. And we're going to use, well, it's going to use a binary search and some hashing. Yeah, and
Yeah.
we're gonna hash every substring with and use a sliding window like that. But we can talk about that. We can talk about that next time.
All right.
Boom. All right, so I'm just gonna write out the beginnings of, is this too small for everyone? Should I make this bigger?
Yes.
Ooh, it's a little too much. Okay. So I just rambled at you for a little while, but we should have a general idea of, like, conceptually, of how we're going to solve this problem. And our first step would be building a grid. So I'm just going to write that out in kind of pseudocode here. We're going to build a grid representing the character. Who has a way to do this? I'm gonna write something out, and I want you to tell me why it doesn't work. That will build the grid, right? Actually.
What is bracket 0?
I'm sorry.
In line 3, what is bracket 0?
So that's going to initialize a list with a 0 inside of it, and then we're going to make an amount of them for each character in S2, right?
Got it. Thanks.
let me just get some. So this made our grid, right? But what's wrong with it? What did we do wrong? Does anyone know?
It's just rows.
We've got
Well, that's just how we printed it out, but it should be a nested array.
Yeah.
Because what the grid is.
Okay.
But yeah, I don't know what's wrong with it.
Okay, so I'm gonna do something here. We're going to assign our first, the first square in our grid, right? Our first spot, our zeroth position. We're gonna set that equal to 1. It's not gonna say that way. I just want to show you what's going on here. All right, so we're gonna run this. All right, what happened there?
You're putting a value in that location at each of those. So that's what we did wrong, right?
Well, but I said just this one, just the first one should be 1, right? Why is it all of them? Why is every row 1?
It's because in the for loop, we're duplicating the first row 4 times.
Yeah, so that's what this is doing here, right? The array with 0 in it, we can times that by the length of S2, and that's fine because 0, we can duplicate zeros. But this one is duplicating an array. So every row now is the same array. It's just a reference to the same array. And that's why grid 0, 0, we set it to 1, and it changed all of our rows. Does anyone know how we can fix this?
Nested arrays?
Yeah, I have a way that I do it.
Like the array from, does that, or is that not any better?
I don't know if Python has something like that. Here's how I do it. I'll show you how I do it. First of all, I'm going to get rid of this because that confuses me, even though it's perfectly legitimate to use that here, because duplicating the 0 is totally fine. But I get confused if I leave that in there. So instead, I'm going to do 0 for, I'm just going to use an underscore because we're not actually using the variable there. And we're going to do zeros for the amount of characters in string 2. And I'm going to get rid of this because that's just duplicating everything. And I'm going to throw this in here for j in, well, we don't need j. We can just do underscore again. All right. So this is what we want, right? Hopefully I didn't just confuse a whole bunch of people.
No, that was cool.
Yeah, that was good to know. Like that's worth my Saturday right there.
Okay, cool. So now we have rows and columns representing each of our characters in their respective strings, and it's not the same array in every row. So we're ready to get started here. And I don't want to actually code out the rest of this. I think that's fine to leave the grid initialization in there. That's something that I think a lot of people aren't, they don't do that every day. But now, what do we do? We have our grid. What was the next, like?
Traverse the grid, right?
Yeah.
Well, or traverse the strings in order to populate the grid.
Yep.
Yeah.
So how do we do that?
well, you would have maybe a pointer that look at the index of one of the strings and compare them. If they're the same, I guess we'd have to like then assign. Well, then we have to look at the -1, and then add it and then stick it in there.
Yeah. So iterating over our grid, that's fairly simple, right? We can just do our for loops here. US1. Okay. So now we're going to iterate up our grid row by row, column by column, right? Just like we did in the beginning with our handwritten version of this. So what are the things that we need to check for? What's the question? When we get to each square, what are we looking for?
If the characters are the same between the two strings.
So I'm gonna do it like that. Check if equal. Okay, so they are equal, right? We're in this. This is probably going to be an if statement of some sort. I'm going to let you all code it though. We're going to do strictly pseudocode from here. I don't want to just code it out entirely. So if they are the same, what do we do?
Hold on there, cowboy. This is a workshop, not an after-hours session.
Thank you.
You want to show us something, show it.
Well, what did we do? What did in the beginning, right?
Yeah. So if it is the same, we need to look -1, back up, and then add to that. But again, I guess it's his prerogative what he wants to reveal to us and what he wants to keep secret like a magician.
Okay, so there's a couple things. If they are the same, we want to add 1 to that -1 position, right? So what do you think is going to trip us up here? There's some like edge cases that we need to think about.
Well, the index error for one.
Yeah. So
If one of the strings is empty.
sure, yeah, it's if we don't have something to check before it. So so in this case, if we're at the first character in either string, there's nothing to check before it, we can just set our spot in that grid. Oh, geez, oops. We know it's going to be 1 because they are the same. There's no previous substring to add on to. We can just make that 1. So then so if it's not AKA else, right? This is our else statement. Then here we need to add 1 to the previous longest common substring. Okay, what else do we need to do? Well, we don't keep a track of anything. Um, so let's keep track of that up here. We can initialize our longest length to 0 in the beginning, and then here.
And the index 2, or are you just assuming we're returning the length?
I'm sorry?
Are we going to keep track of the index to return the actual string, or what did you decide?
I'm going to leave the pseudocode, or mostly pseudocode here as just returning the length, and I'll leave it up to you to figure out how to implement returning the actual string.
I think that I'm going to have to ask for my money back.
Let's see here. So if we'll actually write it out. If grid ij. So this, don't forget to return it at the end. This is it. This is all of it, right? I'll go ahead and post this. I'll post our creation here. What do you think, in general or in code challenge?
Not in, let's see, not in the code challenge team.
No.
Not in that one, but in
Code challenge practice?
general under Py-Lambdas projects, maybe? Or, put it wherever you want to, Brannan.
I'm gonna put it in the code challenge practice. I hope this isn't too big for all of that.
Oh yeah, that's a good call. That's a good place to put it.
Okay, so before I stop sharing my screen and we stop this nonsense, do you have any questions about this?
Given the lousy time complexity, why would you do this?
Yeah, so this isn't great time complexity, right? There's like the brute force solution, which is still going to be somewhat worse. But what is our space and time complexity here?
N squared for both is my first
I'm sorry?
thought. Oh, N squared for both.
Yeah, n squared for both.
So not n squared for both, because you've got two different lists. So it would be like k times, or space would be like k times l or whatever. K times
Yeah,
n.
yeah.
Oh yeah, S1 times S2 length of
Yeah.
those, yeah.
Yes, exactly. We can call that n times m. But I guess my thought process here is we're getting quadratic with it, right?
Yeah, getting quadratic with it. Okay, I'm gonna copy that.
And I'll tell you right now, there are better space and time complexities using other solutions. But using this solution, can we do better? And I'll tell you right now, if someone asks you that question, the answer is usually yes. And so let's think about our space complexity. We're building an entire grid, right? That's what line 3 does. That's how I explain the problem to you. So it's a lot for me to expect you to go in a different direction here. But if we think about what we're doing in our for loop, we never check anything that is more than one row above, right? One row previous. So that means we could keep track of only one row. We would have a variable keeping track of, like, holding one row, like the previous row, whatever we're iterating on, right? It would just keep track of whatever the previous row is, and then we would construct the row that we're working on and put it in, and swap it out at the end of our iteration. So then that would help us in our space complexity.
Yeah, every time I hear that question, my brain goes straight to hash tables because of all the CS stuff.
Cool. All right, I'm gonna stop sharing.
I think Capil did a version before that kind of used graphs, but didn't actually make a grid. He was just kind of making like this kind of like, I don't know how to say it. I have to look at it again, but he was kind of considering like traversing between the things without making a physical like kind of grid, but I don't remember exactly how he did it.
You mean you use a tree?
Yeah, more of like, that type of graph, the tree graph.
Yeah, so there's a couple of other solutions to this problem. And one of them we talked about a little bit, which was using hashing in like a sliding window. And then the other one is using what's called a suffix tree.
That might have been it then, yeah.
And there is a very efficient way to make a suffix tree called the Ukonins. I don't know, it's UKKONEN. And that will build a suffix tree in linear time, and that is the most optimal solution to this problem. And if you all found this useful, we can talk about both hashing and suffix trees in the future.
I would say yes, let's do that, but you have to solve the damn problem. I'm just kidding, Brannan. I also want to point out that your leveling is very weak. Did you see that you just got leveled up?
Oh, yeah, that makes sense. I'm shy.
level 2, dude? Really? That's weak sauce right there. Brannan, thank you. This was cool. I mean, so when you look at applying grids to solve some of these problems, is there a particular class of problem or characteristics of the problem? Like what I'm thinking is sort of like how you determine if you want to use a sliding window is if you're looking for like the largest or the smallest or the somethingest out of two, a string and a substring, then sliding window makes sense for that. So are there characteristics of the problem that make you want to try the grid solution?
Yeah. So definitely when I see like string and pattern matching problems in general, my first thought is maybe we can use dynamic programming to solve this. If it's going to be comparing tons of like a bunch of substrings, then and we're like worried about memory complexity, then I'll probably start thinking about like hashing first. But a lot of the times I'll look at problems and sometimes I'll get stuck. I'll just start drawing out a grid. Physically drawing stuff helps me a lot with these problems. And sometimes, you know, my brain's not really going in the dynamic programming direction, but I draw out the grid and I go, oh, okay, so we can just, you know, line up the characters, and then, you know, it ends up being a dynamic programming problem.
When you say hashing, do you mean just using like dictionaries? Is that what you mean, or do you mean something else?
So yeah, so like dictionaries and sets, that's like
Yeah, like that category. Is that?
So there's some hashing algorithms that we can go over in the future that that makes like this pattern matching stuff much more efficient. So in this instance, no, I'm not talking about dictionaries and sets, although we will use them in the problem.
What was the name of that other graph thing that you called it? I've never heard of that before. I'm web, I'm not data science, so I'm thinking that's probably a data science thing. But you mentioned when you said hash tables, there was something else you said we could go into hash tables or this other thing in the future, and I'm not familiar with that other kind of graph.
The name of the suffix tree.
The suffix tree. Did I miss that somewhere? Because that's new to me.
No, that's
Yeah.
not in the web curriculum either. Yeah, and specifically like Euclid's, or however you say it, that's a pretty academic subject, to be honest with you.
Well,
Yeah, when you get into data structures and algorithms, there are lots more than what we get exposed to at Lambda School. Lots more.
right, and I'm totally interested in that.
Cool.
It doesn't scare me.
Awesome.
Well, then you're gonna be a welcome addition to Py-Lambdas and the Discord server then, because we should be talking about all that kind of stuff.
Yay.
So I'm just going to add this because I like the idea that when you do something operationally, you define terms so that everybody's talking about the same thing. According to Wikipedia, dynamic programming when can be either a mathematical construct or a computer programming construct. And in computer programming, there are two key attributes that a problem must have in order for dynamic programming to be applicable. Easy for me to say. First is optimal substructure, and the other is overlapping subproblems. If a problem can be solved by combining optimal solutions to non-overlapping subproblems, the strategy is called divide and conquer instead. This is why merge sort and quick sort are not classified as dynamic programming problems. So you can Google Wikipedia and dynamic programming and find the definition that I just shared with you. And I think I'm also going to, let's see, find where the code challenge thing. So I'm going to add that link to Brandon's posting of the code in code challenge practice. Okay.
I've always found that like people, I've read so many descriptions of what dynamic programming is, and I can't say that it's it's kind of a squirrely concept, and I just haven't found it useful to like argue with people about what the definition is. So to me, there's like a couple of different categories to dynamic programming problems, and this is one of them, right? Is like matching patterns together.
And what's the others?
So another one would be find the most you can get out of something, right? The knapsack problem, and there's variations of the knapsack problem, right?
Optimal substructure is what that would be.
And then there's Fibonacci, like specifically counting stuff. If you can break a problem down to this is kind of like the Fibonacci sequence, that's also dynamic programming.
overlapping subproblems. Yeah, so you know, when you, okay, this is almost, I'm getting almost as anal about this as like a grammarian gets when, you know, you're not speaking the King's English, but you can operationally define something. It's like, okay, in this case, with what we're about to do, this is what dynamic programming is. And that sort of handles anybody's desire to argue, because it'd be, well, okay. But in other cases, it may be something else. But in this case, dynamic programming is X. So now that I've nerded out on that.
Yeah, that was fun. Thanks for listening to me ramble, everybody.
Hey, thanks a lot for this. Appreciate
Yeah,
it.
thanks so much.
Yeah, thank you.
Appreciate
That's
it
great.
and stuff.
All right, Brannan, thank you very much for doing that. I appreciate it. If you guys, any of you guys want to present on a topic, it doesn't have to be as complicated and sophisticated as the one that Brannan just did. But if you want to talk about anything that's Python related, feel free to, you know, drop a note in the, there's a category of channels at the bottom called Py-Lambdas projects. And one of those is weekly presenters. And so you'll notice that a couple of people have dropped some thoughts on doing other talks. Obviously, this is a really good thing for your portfolio, for your presentation to hiring managers, whether you're on your first job, trying to land your first job, or trying to land your second or third job. These kinds of talks are always really useful. And also it prepares you to do, you know, you're in a pretty friendly audience with our group. And so it will prepare you to do this in, you know, larger audiences. So I would encourage you all to take advantage of it. And again, it doesn't have to be a really sophisticated topic. It can be something really straightforward, like, you know, so you could do a talk on PEP8. You could do a talk on some aspect of the standard library, or anything, really.
Please, someone do a talk on PEP8. I need that.
I noticed. Okay. So yeah, or even like you could do a talk on what are PEPs, right? So there's like 500 PEPs. 8 just happens to be the style guide. Does anybody have any questions, comments, complaints? All complaints should go to Brannan. Okay, great. Well, thank you for joining. We'll do this again next Saturday. I don't think we may or may not have you know, someone doing a workshop or a presentation. If we don't, then we're going to do some code challenge problems or anything that that you want to bring with you. If you want to bring a code challenge problem and have us look at it collectively, that's a great idea. If you have any code that you are struggling with, that you're blocked with, and you want to get some help or advice, definitely bring that. So yeah, until next week, we're done. Thank you all.
Thank you.